Alright YouTube, hello, thank you for watching. Today I'm buttoning up some things on this JVC here. Next month I am going and getting some lights. I don't know how much it's going to benefit you, but I know it would surely benefit me in more ways than one, just to put it to you that way. So anyway, I got this JVC sounding pretty good. It's still got a little bit of room to go, but I think I'm kind of at the point with this where I can button it up until I find a way to replace these op amps in this. And I don't want to get too sidetracked. Putting videos on YouTube is extremely hard. And the reason that is because doing electronics is extremely time consuming. It's extremely tedious. And, you know, if I came right out and told you how long it takes for me to take an hour and a half of video footage and condense it and keep some accuracy and flow into it, you won't even believe me. So a lot of the problems I had with this amp is it didn't have any real amount of high frequency boost on the loudness switch. It didn't have any clarity on the high frequency end. It didn't have any soundstage or presence to it. Now the soundstage won't actually happen until I get those Hitachi op amps out of there, but you should still have a little bit of presence with an amp just doing the changes that I did here. Now what will give you that presence is replacing the input lines, and I generally don't do all of them. I'll do them in kind of like select pieces. Replacing the op amps will definitely get you soundstage in an amp, provided you've made all the other changes in the amp that I have in this one. So just kind of rehashing here in order to make this as simple as I can. I think that's about the most light I'm going to be able to get. I like to do things in a way that could actually help somebody. Yeah, well, that's all I'm going to say about that. I like to do things in a way that could actually help somebody. So I replaced all the caps on this EQ board, all the audio path caps, which equated to 4 coupling caps here, electrolytics I replaced with UKZs. There was 4 coupling caps down through here. I don't have the numbers offhand. They are all 2.2s and 4.7s, I think, in this row top to bottom. I pulled all the film and foil Mylars, which I used the phrase technically they're about as good as you get. I pulled all them out and replaced them with Panasonic PPS chips, with the exception of one pair of them that I didn't have a PPS chip value for, so I had to use an MKS capacitor. But all the rest of the PPS chips are mostly on the back of the board. There's 2 of them up here. There you can see one. And I replaced these 4 coupling caps here that I'm still not sure. I made the statement that these caps come in on the equalizer bypass. But the way this unit is laid out on the schematic, it doesn't have any flow to it from left to right and no continuity top to bottom, or actually vice versa. So it's very hard for me to tell from the schematic exactly what is doing what, because typically when you take the EQ out, it will throw an alternate audio path into the loop, which generally, in most cases, has coupling caps in it. Now, in order to try to get the high frequency response up, the first thing I did was I paralleled 4 one mic PET dielectric caps across the back of these 47 mics to bypass some of the high frequency response around these electrolytics, since they have dielectric loss to them at high frequencies. They're audio grade electrolytics, but they still fall short. So there's actually 4 one mic bypass caps going around these on the back side of the board. The changes to the loudness control, and I think there was a video that covered the basic location. Down here was 1, 2, 3, 4 caps and 1, 2, 3, 4 resistors. They are R295 And there's going to be another one that's going to pair with 295. I don't know if it's 294 or 296. I just can't see it down there. But those were the bass boost caps for the loudness. The original resistors in those two positions were 20Ks. I reduced them down to 15K to bring the bass boost shelf up on the bottom end in amplitude. Now the other two resistors, one of them is R293, and then whatever matches, looks like it's R294 maybe, were 33K resistors. And that's a very, very high value, meaning that doesn't give you much treble boost on the loudness circuit. It's very unusual that you see resistors that high. Why they did that, I'm not quite sure of. It's very, very out of the ordinary. But I changed them from the 33Ks. I reduced their value down roughly 81%, down to 6.2K. Let me see if there was anything else. This I know my video covered, probably my first video, was replacing those two bass boosts on the loudness control. I replaced them with 033 Panasonic PPS chips. The treble boost, I did a little bit something different on that because it was kind of a big ditto of the resistors for these two caps. These two caps were a pretty small value, which typically you would see that value stand alone if there was no resistor in series with it. But when you put a low value cap like that in series with a high value resistor, it really doesn't give you anything in treble boost at all. So those two work together, those 6.2Ks and these two 330 caps. These were originally 330s. I put 330 PPS chips in them, and then I just went back the other day and paralleled another 100 puff across the 330s. So they're 430s. To take them any higher than that, I'm not sure that that would necessarily be a good idea, at least at this point, until the op amps, in my case, are gotten out of there and changed. So those were the changes to the loudness button here. Now there was two other changes that had a significant effect. Down here on the amp board, these are your FET inputs to your amp. It's a differential pair of, I don't know if they're JFETs or what they are. I probably should know that, but I didn't even really pay attention to it. Now there's an RC network that goes across that differential pair. And I just don't remember because it's been a while, but it has something to do with common mode rejection. And in any case, what was in here was 470 puff ceramics. Ceramics are, in large percentage, never the answer in really any part of an audio circuit. I don't know if I want to stick my neck out as much as to say that or not, but I just did. And thinking about this the other day, I just happened to catch that, and I thought, I wonder if that's not some of the problem with those caps there. And when I looked on the schematic, I said, yeah, I can guarantee they have ceramic caps in there. None of my other amps have ceramic caps in them at all. In regards to my Sansuis and stuff like that, they all generally had polypropylenes at this position. So anyway, I pulled those 470 ceramics out of there. One is there. The other is up here, down there in the shadows where you can't really see it. And I put some FKP2 470s, but to the 470 version of the FKP2 that are actually classified as film and foil. There's like two different variations on those FKP2 series caps. So that squared a lot of things away too. Really, honestly, there wasn't any one thing in particular, or two things, or three things in particular. When you're doing an amp, you got to pretty much get everything. That's why, I kind of like to do them all at once. But I mean, who could really do that? You'd be up for 3 weeks. That way you can get the full effect of them and just get the full Monty, man, going from you know, what it was when it came through the door to flipping the switch on, and it's like, feels like it's a whole other different amp. But anyway, enough of that craziness. There you can kind of see one of those one mics sitting on the back side of the board that I paralleled down along those 47 electrolytics there. Like I said, the rest of the PPS chips for this equalizer are on the back of the board, with the exception of these two big chips. I just stuck them on the top. The only thing left to do is to do the signal lines. And signal lines and op amps kind of go hand in hand in the scheme that I go through these at. So I'm not really sure if I want to go ahead and do a signal line at this point or not. Because once you put the op amps in, that can change a lot of things that you did with the amp because of increasing the slew rate of the op amp and stuff. So it's generally not a overwhelmingly great idea to make a lot of high frequency changes until you get your old op amps out and get some hot op amps in there. Generally, I don't replace all the audio lines on my amps because I only run CD input. That's where you got your most dynamic range. So generally, I always just do the auxiliary input line. The tuner lines I generally don't do unless I did a tuner up to get some more definition out of them. This line down here, I honestly don't even know that I would waste my time with it, with replacing that. I would go right to the longest line to start with. And like I said, I generally do not do all of them. Because if you put a hot op amp in there, you got PPS chips in there, and you start sticking silver lines in there, then you can run into a problem. And that's why some time ago, I tried an experiment of running copper lines instead of silver lines. Silver can get very, very bright, especially when you got PPS chips in. They have excellent frequency characteristics, so they're just going to let any kind of brightness come right straight through. There is some music out there that doesn't do well with it, but if you got good mastering, it usually does well. Kind of the clincher is to find CDs that are mastered well. Now I will say this, I generally don't do phono boards because I don't use phono. There was a couple cases where I did a conversion on a phono board. So actually I converted the phono board to a laptop input in order to run a laptop into it. I did that on I think my D5 and my D7. In that case, I redid some of the components, well actually a lot of the components on the phono board. So anyway, I'm going to put this guy back together and continue to enjoy it here until I figure out what to do with the op amps. The problem with putting other op amps in here is a couple of problems. The one problem is the way the schematic's drawn. I can't make sense of it. The other problem is they threw two transistors into the schematic, into the op amp circuit, which doesn't make sense to me what it's actually doing because it's not drawn right. These op amps here will take 50 volts as much as an absolute max of 50. According to the schematic, they're setting at about plus and minus 26 to 27 volts on the plus and minus terminals. My experience has usually been the voltage on the schematic is a little bit higher than what it actually is. Because, like I just said there, I said the maximum voltage on these is 50 according to the manufacturer's information. But if you look on the schematic, it says roughly 26 to, I think it was like 26 point something. So if you take plus and minus 26 point something, of course you get more than 50 volts. So I think it's actually lower than that. But the problem is the LME 49860 op amps, the absolute max is plus or minus 22 and a half. If I'm not mistaken, it might be plus or minus 22, but essentially 45 volts. So you know, the difference of 5 volts is actually enough to be an issue. So that's kind of the hold-off. The only thing that can be done there is to regulate the new op amps that you put in at a lower voltage. and that takes a lot of work to change voltage regulators around and add stuff into the circuit. So, but hey, anyway, I appreciate you watching my videos very much. You take care and have yourself a great day.